Take question number 24 in the tute. Question number 24 in the tute. The first question today, question number 24. Right? Yeah. Read question number 24, people. Right. Question number 24, people says, in each of the following cases, sketch in an Argand diagram the locus of the points represented by the complex numbers is it satisfying the given conditions. Right. First condition given, ask people this. First part, imaginary part of Z greater than 0 and mod Z minus 2 equals 2. The region, right, satisfying this. Okay. Okay, people, now this isn't these people a variable complex number? No, it is a variable complex number. So this is a variable complex number, right? Okay, because satisfying this mod z minus 2 equals 2, people, there are infinitely many complex numbers. No, this is a complex number. Subtracting 2 from that, and when you take the modulus should be equal to 2. Satisfying that condition, there are many complex numbers for Z, right? And here also, a complex number Z we have, its imaginary part is positive. People, not only one complex number in such a way that available satisfying this condition. Okay, there are many. So therefore, you can very clearly understand these two together give two paths. Now asking what people, right? For these two paths, the common region, no? Okay. People, now I am going to assume in this case a complex number for Z. A complex number for Z I am going to assume as this way. Let Z equals x plus iy, where this xy both are real numbers. Xy both are real numbers, people. Then you can very clearly understand there real part of Z. Therefore, real part of Z is x and imaginary part of Z is y. Then imaginary part of Z greater than 0 mean what, people? Y is greater than 0 implies y greater than 0. Y greater than 0. People, what is y? Simply assume this y as y coordinate, the same thing, no? In the Argand plane, we define that y coordinate as imaginary part, no? But it is very similar to y coordinate. Just think that in OXY plane, y coordinate should be positive. People, what is that range? Y coordinate should be positive. Yeah. If this is the Argand plane, real axis, and this is the imaginary axis, right? Imaginary axis is nothing but our y axis, right? Like this. Then y positive mean, people, above the real axis this way. This the y positive region means above the real axis this way. Okay. Right. Second one is mod z minus 2 equals 2. Second one. Mod z minus 2 equals 2, people. Can someone tell me what is the corresponding path for this? It is a circle. Where is the center, people? Center is at the complex number 2. 2 is purely real. Radius is 2. This is a circle. Center is at the complex number 2. Complex number 2 means purely real. On the positive real axis, at the value 2 is the center. Radius is 2, people. Therefore, that circle should be this. Right? People, to my place, it's heavily raining. Sometimes Wi-Fi connection may be dropped. Don't leave the class, right? Stay. Okay, this is a circle. Center should be at the real number 2 on the positive real axis, right? So then this is a positive real axis. Since the radius is 2, people, this is 2, this is 2, the complex number here 2 on the real axis. Therefore, this circle should touch what the y-axis where at the origin, right? So therefore, the y-axis, that in the sense imaginary axis, should be passing like this. Should be passing like this. Okay, like this. People, this is the path on the circle, on the circle. Right? This is the path. On the circle is the path given by this. Okay, right. Now we need to find the common region for this and this. The region for this and the region for this. The common region. Yeah. Now this region, if I again shade, that should be above the real axis. Because we need the common region for this region and this region. Right. Since this region is above the real axis, our required region should be above the real axis. Above the real axis on this circle. Therefore, the common region going to be, people, above the real axis means we have to pay our attention on two part above the real axis. That means above this line and on the circle. Therefore, the common region going to be common region, people, right? Common region going to be what? Common region going to be this part, no? Right, our region is not inside the circle, right? On the boundary of the circle is this region, right? Okay, then that common region going to be this. Right, like this. Now, people, you know, y greater than 0 means we can't take y equals 0 because we don't have equal sign here. We don't have equal sign here. So therefore, can we consider on the real axis? No, we can't. Above the real axis. Then if I put like this, people, this end of the circle now on the y-axis, sorry, on the x-axis, people, and here both. On the x-axis, y0. But here, y greater than 0 means y equals 0 not available there. So therefore, you have to exclude these 2 points. Both points you have to exclude. This and this both we have to exclude. If you don't exclude these 2 points, people, you lose 5 marks, remember, because here we don't have y equals 0. Understand? So therefore, this is the common region for both. This is the imaginary axis, this is the real axis. So therefore, this is the region satisfying that imaginary is greater than 0 and right mod z minus 2 equals 2. Mod z minus 2 equals 2. That is the region, right? Okay. Right. Second one, people. Second one, right? Number 2. Take number 2. Second part given, imaginary part of z. Imaginary part of z greater than or equal to 0. And the second condition, mod z minus 2 equals mod z, people. Like this. Okay. Mod z minus 2 equals z. Right. People take that imaginary part of z greater than or equal to 0. Secondly, mod z minus 2 equals mod z. Right? Can you sketch this common region for both? Right. Try to sketch this. Right now here, imaginary part of z mean, people, y no? Y greater than or equal to 0. In this time we have equal sign. People, what is this? This one you can write z minus 2 mod d equals this z I can write z minus 0 mod like this. People, can you remember? We consider this way a path. What is this path? So this is a variable complex number. What is this path? This path is, people, the perpendicular bisector of the line segment joining the complex numbers z1 and z2. When you join z1 and z2 by a line, we get z1, z2 line segment. Then this path mean, people, through the midpoint of this line segment, we can draw a straight line perpendicular to this line segment. Then this z mean, people, any complex number on this line. This path we identified in the theory class. Okay, like that. Here you can very easily see this z should lie right on the perpendicular bisector of the line segment joining the point corresponding to the complex number 0 and 2. Complex number 0 is on the origin. 2, people, purely real. on the positive real axis at 2, right? So then this one we can write like this. Real axis, imaginary axis. Therefore, including now this time, this means including this, right? This one we can take right. 2 is here. Zero is here. We can join them. Its midpoint is exactly 1, no? 1. Here we can draw a line perpendicular to this. This is the right. Okay, path. Then people tell me, what is the common region for both? The required region should be on the real axis and above. And the required region should be on this line. Understand? Because here we have and this condition as well as this condition. Both should satisfy simultaneously. Right? So then y greater than or equal to 0 mean people on the real axis so above. Because equal sign also in this case available. Right? Our region should be above the real axis or on the real axis. And people, the other thing is our region should be on this line. Then common region should be people where? Right. Common region going to be this. On the line this. But above the real axis. And including this point. Because at that point you know y coordinate 0. Y equals 0. Understand? So then this is the required path. Here it's 1. Including 1, the path this. This is a common region. Right? No? Right? So then this is the path for this and this both. Right now, people. Right. Imaginary z greater than 0 and that mod z minus 2 equals to is this path. Right. Okay, no? Now another part is there, people. What is that? Find the complex number right. Now people, this and this I am going to draw in one diagram. Okay. Yeah, ask in this one next. Find the complex number z that satisfies the conditions given in both 1 and 2 above. Right. Number 1 is this, people. The complex number lies on this arc. Number 2 is this. Here, this is 1. This complex number here is 1. Now, if I draw both on the same diagram, if you draw on both on the same diagram, people, right? So this is the center. Center we notice here 2, no? This is 2. And now the line, this is passing through 1. This is 2. This is line, people, now. So number 1 is this, people. Number 2 is this. For this number 1 and number 2, to satisfy the condition given by number 1 and number 2, the single complex number is the complex number at the point of intersection here. This is the required complex number we need to find. Okay, right. This is 2 complex number. Right. Now you can very clearly see here that is a point on the Argand plane. Okay, that point has x and y coordinates. X coordinate is the real part, y coordinate is the imaginary part. Then you can try the complex number. So then we need to find that complex number, people. You know already the x coordinates 1, people, here. This is 1. This length is 1, no? Then real part of the complex number represented by this point is known. And this height we need to find, people. Y. That is the imaginary part. Now, using your trigonometry knowledge or geometry knowledge, you can find that height, y. Then you get the complex number in the form x plus iy, right? Take that one, people. Given by this z. Yeah, this y you need to find, no? This y you need to find. That y can easily be found, people, if I join this point to the center here too. People, this length from here to here, it's radius, no? Radius is 2. This is 1. And from here to here, also 2. Then this also 1. Okay. Then you can write by using Pythagoras theorem. By Pythagorean theorem, y squared plus 1 squared equals 2 squared. This is nothing but 3. Y is, people, root 3. It's obviously positive, no? The y coordinate. So therefore, we don't take minus sign when you take the square root. So therefore, the complex number you can write. Therefore, the required complex number is it equals x means 1 plus root 3 I. 1 plus root 3 I is the required complex number. Right, no? Yeah. Right, take it's part B, people. Take part B. It's part B. Part B is this. Z equals x plus iy be a complex number. X and y are real numbers. Define the modulus of Z. What is it? This, no, people. Its modulus is this, no? X squared plus y squared root, right? And the complex conjugate, Z bar going to be, people, x minus iy. Show that mod Z squared equals Z bar, right? We'll write Z bar product first, right? X plus iy into x minus iy. x squared minus iy perfect squared. So this is y equals x squared. I squared is minus 1 and here then plus y squared. X squared plus y squared means people square of this. That means mod z squared. That is okay. And z minus z bar. Z minus z bar is really x plus iy minus x minus iy. No, this and this we can cancel down. This is nothing but 2iy. Z minus z bar. 2i. Y means really even part of y. Sorry, immediate part of z. Hence show that mean people using this results. Using this result, just now we proved, we have to take this answer, right? Okay, right. Try to prove that, people. Hence prove that. Hence prove that. Z plus 4i modulus perfect square. Z plus 4i modulus perfect square. Try to get this answer, people. Okay, now people, this is how we think there. We need to find the modulus of the complex number z plus 4i, right? You know, people, this one here, z is a complex number. 4i is a complex number. Both z and 4i are complex numbers. Then sum of these two complex number, we proved, people, we showed the sum of two complex number is another complex number. Understood? So therefore, this z plus 4i is a complex number. Now, if I take this whole z plus 4i complex number as z1, now z plus 4i modulus squared mean, people, z1 complex number modulus perfect square. This is what asking really. Understood? Okay, I am going to take z plus 4i. It is a single complex number. No, I am going to take that as z1. Then z plus 4i modulus perfect square mean really what? Z1 modulus perfect squared. Mod z1 perfect squared. People, we know perfect square of the modulus of a complex number, right? Today we just now proved z mod perfect squared is equal to z bar. Then here, this one really z1 into z1 bar, right? Z1, people, therefore this no z plus 4i into its conjugate, this way. Then I can write z plus 4i modulus perfect square is equal to what, people? Z plus 4i, right, times z plus 4i conjugate. Understood? Right, no? Yeah. So then I can write this one z plus 4i into z plus 4i conjugate. Right. Now, people, secondly, we proved another result like this. We proved, people, like this: z1 plus z2 conjugate, right, is equal to z1 conjugate plus z2 conjugate, like this. So therefore, here, people, this z is a complex number. 4 times I, 4I product is a complex number. Then that conjugate this we can apply on this and this both. Right. Write people like this. And furthermore, people, you know, when we have a product of two complex numbers, Z1, Z2 conjugate bar is equal to people, we prove that also this way. Z1 bar into Z2 bar. Understand? Then here, if I consider 4I, people, 4 is a real number. Any real number is a complex number. It's like this Z1. I means people 1I. 1 times I. 1 times I means, right, purely imaginary complex number, right, here. Its conjugate. Okay. Then we can apply this bar for this 4 and this I separately. 4 conjugate I conjugate. People, if the complex number is purely real, if the complex number is purely real, for example, this we did last time also. Suppose the complex number is x plus iy. Remember, people, last Friday, that means it was 7th, right? No, 6th Friday. Right now, 6th Friday, people, Friday class, I did 2 questions. The people who didn't get this recording of the Friday class, watch that recording. There are 2 questions. That 2 questions I am not going to do today. Watch them and complete that notes. In that recordings, people, I detailed explanation available. Again, when the complex number is purely real and purely imaginary, what is its conjugate? Right. Suppose now complex number is Z people, then Z bar going to be x minus iy. Okay. Then suppose x is 0. When x is 0, complex number is iy. Then its conjugate is people here x0 minus iy. Therefore, this says what, people? When the complex number is purely imaginary, its conjugate, to obtain its conjugate, people, that complex number should be multiplied by minus sign. Okay. Now, suppose secondly y0. Y0 means Z equals x. Y0 means Z equals x. Then what is Z bar? X. What is this, people? When y0, the complex number Z is purely real. Of a purely real complex number, conjugate is the same. If the complex number is purely imaginary, its conjugate can be obtained multiplied by minus sign. Understood? So therefore, here you can see 4 purely real. Its conjugate is the same 4. People, I means 1 times I know. Here, if I put for this y1, we get I into 1. That is 1 times I. That is I. Okay. Then the conjugate of I going to be minus I. So therefore, people, this is minus I. Okay. Then I can write in the next step, people, here Z plus 4I, right, times Z bar 4 bar. It's 4 I bar, people, minus I, right now. Then this minus sign I can write via here. Next step. Like this. Now you have to remove the brackets. Multiplying, remove brackets. Now you can write Z into Z bar, Z bar. Right, people? Here Z for Z I. And here people, for Z bar I. This and this minus 16I squared. You know people, Z bar is mod Z squared. And here you can take 4I out. Once we take 4I out, here we get, we'll take people minus 4I out. Minus 4I out when you take, here we get Z and here minus Z bar. And I squared is minus 1, that and this make plus 16. People, what is Z minus Z bar? Z minus Z bar, we proved if Z is X plus IY, Z bar going to be X minus IY, then Z minus Z bar going to be what? This and this will cancel off. Here 2IY. 2IY. So therefore this is equal to 2IY. 20Z squared minus 4 times 2IY plus 16. Right? People, really it is nothing but in another way we can write 2IY without writing 2IY here. I write that 2IY there. But this Y is what, people, really? 2Y times this one we proved in the theory part in the same question. This Y is what? Imaginary of Z. Correct? No? Imaginary part of Z. So therefore, I can write this I and this I is I squared, people. I and I, when you multiply, we get I squared. That I squared is minus 1. That minus and this minus make plus. 4 into 2 is 8. Okay? Then we get mod Z squared. I and I squared minus 1 and plus 8. Plus 8. Here Y mean, people, right? Imaginary part of Z, no? And plus 16. This is the Z plus 4I mod perfect square. Correct, no? That answer coming like that. And people, the next one take. Secondly, another similar result to be proved. 1 minus 4I Z mod perfect squared. 1 minus 4I Z mod perfect squared. Correct, no? This one, okay now. Next one, take. Take second answer. It is, people, now 1 minus 4I Z perfect square, right? So then this is the complex number. 4I Z is a complex number. People, you know, when we consider product of 3 complex numbers is another complex number. The reason is this product I can consider like this: Z1, Z2 times Z3. Z1 and Z2 are 2 complex numbers, no? Then their product is another complex number. We have proved that. Therefore, this is a single complex number because we have proved product of any 2 complex numbers will give another complex number. So therefore, for Z1, Z2 product, we can write one complex number as Z. that Z is a complex number, Z3 is a complex number. Then again, there we have product of two complex numbers. Therefore, the final result is again, since product of two complex numbers is another complex number, then to this product we get a single complex number. Okay, right? So then people, this is a complex number. One is purely real, a complex number. Then here we have difference of two complex numbers. So therefore, within this modulus we have a single complex number. Its modulus perfect square only asking. We know people, perfect square of the modulus of a complex number can be written as the product of the complex number multiplied by its conjugate. Understand? Perfect square of the modulus of a complex number is equal to that complex number multiplied by its conjugate. So therefore, I can write this one also this way: 1 minus 4iz times 1 minus 4iz conjugate, like this. People, can you remember we proved under theories Z1 minus Z2 conjugate is equal to Z1 conjugate minus Z2 conjugate. Using that, we can apply the conjugate for this one and this both, right? 1 minus 4iz equals 1 bar minus 4iz bar. And people, you can remember, I'm going to take this way, Z1, Z2, Z3. I'm going to consider its conjugate. Okay. Then I can consider this one, Z1 and Z2, as one complex number and Z3 as another complex number, like this. Right? This way I can consider. Okay. Now people, Z1, Z2 product is a complex number, no? Then this Z1, Z2 product, instead of that Z1, Z2 product, we can write single complex number like Z. Then here on the right hand side, you can think product of two complex numbers we have. Its conjugate mean we can apply conjugate separately on first and second complex numbers. So therefore, this one I can write people Z1, Z2 conjugate into Z3 conjugate. Now again, if we consider this Z1 and Z2 are two different complex numbers, people, there what do you have? Product of two complex numbers, its conjugate. That one we know, people, we have proved in the theory class, right? This is a bar we can apply on this Z1 as well as Z2, and then we get like this. Right, people? So therefore, you can very clearly understand Z1, Z2, Z3 product conjugate is what? Product of the conjugates of each complex number. By using the mathematical induction, we can prove whatever the number of complex numbers here we have in the product, its conjugate is equal to product of the conjugates of each complex number. So using that fact, people, this one I can write 1 minus 4iz 1 bar. Since this is purely real, people, the what conjugate is the same. I can apply this conjugate for this 4 I and Z like this, right? Using this theory. Okay. Now see here, though you knew the theories, the way you have to apply the theory, you should know by, of course, doing some sums. Understand? So that is the one we say usually, though we complete the theories, people, completion the theories of any lesson doesn't say that you can do all the questions. So the way you apply that theories, of course, should understand, learn by doing sums, right? Now here 4 is a purely real, conjugate is 4. I, earlier we noticed conjugate of I going to be minus I, people, Z bar, right? So then we get here 1 minus 4iz and 1 4 bar is, people, 4 I bar is minus I, that minus and this I, right, people, minus I, that minus and this minus plus, and I and Z bar. You know, I bar is what? I bar is minus I. Minus and minus plus I. Now multiply this. By this one, we multiply this. This and this we can multiply, minus 4iz minus 16 I squared z bar. This will be it. Huh? Right, now I can write here. I will take people here minus 4i out. Once I take minus 4i out, here we get z minus z bar. Here I square these people minus 1. That minus and this minus make plus 16. Z bar means people mod z squared. You know what is z minus z bar? Z minus z bar we notice 2i imaginary part of y. No, can remember that earlier we did that. No, z is x plus iy, z bar x minus iy, then z minus z bar is 2iy. 2iy means this y is what? Imaginary part of z. No, then I can write for z minus z bar 2i imaginary part of z plus 16 mod z squared. Then here this I mean people I squared is minus 1, then this is plus 4 and 2 is 8. Then we get the second answer too. One minus 4i z mod of x squared is equal to 1 minus minus plus 8 IMZ plus 16 mod z squared. This will be good. Right, next one, people deduce that z plus 4i greater than z plus 4i modulus greater than modulus 1 minus 4i z if and only if mod z less than 1. Right. Okay, we'll count that. Z plus 4i modulus greater than 1 minus 4i z. If and only if, yeah, mod z less than 1, right? People, now starting from here, we'll prove mod z less than 1. Right? How to prove that? We'll square both sides. This implies what, people? After squaring this, what we get? So both sides are positive. No? Why? How can you say that both sides are positive, people? Both sides available modulus of a complex number. Modulus of a complex number is, people, a positive value always. So therefore, both sides positive values available of this inequality. So you know, if both sides of an inequality positive values available, we can square both sides, right? Okay. So then we can write z plus 4i mod of x squared 1 minus 4i z mod of x squared. People, now here we can substitute for this z plus 4i mod of x squared. Okay, the answer we found there earlier, and this one, both sides we can substitute. Okay, so this one, you know, z plus 4i mod perfect squared going to be mod z squared plus 8 im z. We proved this, no? Plus 16 greater than here 1 minus 4i z mod perfect square. It's 1 plus 8 im z and 16 mod z squared. Well, this 8 im z and this you can cancel off. Then bring this 1 to this side, then it will be 15 greater than 16 mod perfect square. Bring this right hand side, it is 15 mod perfect square. These two again you can remove, right? Then we have here 1 greater than mod z squared then take the positive square root on both sides. Then we get smaller than mod z. That says people the required answer. Mod z less than 1. Okay. Now, if and only if proof people here we have, we'll take the say backward arrows here. Then that proof is okay. Right, next one, people. Read next part. Plot the points that represent the complex numbers z satisfying the conditions z plus 4i greater than z plus 4i modulus greater than modulus of 1 minus 4i z and arg z pi by 4. Okay, people. Right. Now, try to sketch that common path, people. Now, see here, we are asked to construct the common region for this and this. People, now this means mod z less than 1. Right. We proved, no, by if and only if this becomes true, then that implies this. This implies this. Both directions we proved that. Now, what is this region, people? First, ignore this less than sign. Instead of that less than sign, put equal sign. Mod z equals 1. People, you can think it like this, no? Z we can write as z minus 0, no? Z minus 0 is nothing but z equals 1. What is this, people, really? When z is a variable complex number, z minus 0 mod 1 equals 1 mean, people, what? It's a circle of radius 1 and center at O means origin, like this. Then this is the mod z equals 1 region on the circle. But what region we need, people? Mod z less than 1. Less than 1 mean people inside the circle. Really, this means z is a complex number. Its modulus is always less than 1. People, modulus of a complex number mean what? The distance from the origin to that point represented in the complex number z. The length of the line segment starting from origin, ending at that complex number is the modulus. If that modulus less than 1 mean people that all complex numbers should lie in the circle whose center at the origin and radius 1. Therefore, mod z less than 1 mean people inside the circle. So in this case, really remember, since we don't have equal sign here, okay, the region, this one is nothing but when I construct the circle like this, since here we don't have equal sign, we have to draw this way, broken line segments. Then this is the region inside circle. Mod z less than 1. And what is this region, people? Arg z. Arg z. Pi by 4. This way we can write that. What is this, people? A straight line starting with the argument. People, you know the path is a straight line, no? It is starting from where? 0. That means origin. Making what? Pi by 4 angle with what? Positive real axis. Right? Then that path is this. This way. Right. Now, people, what? The region common to this and this. That means this and this both we have to draw in the same diagram, and we have to find the common region. That is a required region of Z satisfying the both conditions. Right. People, once you draw both in the same diagram and find what is the region, the common region. The common region for this and this. The recurrent region should be definitely on this line. And recurrent region should be definitely inside this shaded region. Then we can draw that one. How, people? Here this point is excluded. Right? On the line, we can consider up to this circle, the radius of the circle, people, we notice 1, no? So therefore, this is the required region. This is 1, this is pi by 4. It is a common region for both. inside the circle and this line, the common region, this portion of the line, excluding both the extreme points of the line segment 1 unit length, making an angle pi by 4. Understand? So this is the required region for this and this. Right. The required region is, people, this. This is a required region. Okay, no? Take number 20. Question number 20, people. Take. Read question number 20 and try to get the answers, first answers. Right. Question number 20. Z be a complex number? Prove that. Right. We'll take this Z dash, let Z equals x plus iy. Then what is, people, Z bar? Z bar is equal to x minus iy. Then here, real part of Z is x, imaginary part of Z is y. Here, real part of Z bar is x, imaginary part of Z bar is, people, minus y. Yeah? We have taken this I before, include this minus sign with y, minus y. I means Z bar is minus y. Right. Now asking to prove this way. First one. If real part of Z is 0. If real part of Z is 0 means, people, what is x? Real part of Z means x, no? Then I can put for this real part of Z place this x. This implies x equals 0. People, if x equals 0, what happened to this Z? Iy. What happened to this Z bar? Minus iy. Then we can write, if x equals 0 means Z is iy and Z bar minus iy. If x equals 0. Then, people, you can very clearly understand. Okay. I can multiply both sides of this minus sign. Then we get minus Z bar equals iy. Iy is Z. Therefore, these two, by combining these two, we can write Z equals minus Z bar. Right? If the real part of a complex number is 0, that says the complex number and minus conjugate of the complex number are equal. Right. Secondly, people, if imaginary part of Z 0, if Im Z 0, imaginary part of Z means y. This is y. Y equals 0. If y equals 0, what can say? Z becomes x. Z is x. And here, y equals 0, Z bar also x, people, no? Then you can see y0 means Zx, Z bar also x. Then we can write, therefore, Z equals Z bar. Right, okay. Next part, people. A complex number u is defined as u equals 10 upon 3 plus I plus 13z divided by 2 minus 3i. U equals 10 divided by 3 plus I plus 13z divided by 2 minus 3i. Right, so this is a complex number. Show that u can be written as this way. You can written as this way. Right. Who proved this, people? Good. Yeah. Right. Okay. We can prove it like this. The numerator and denominator of this we multiply by the conjugate of this denominator. It is 3 minus I. No. This and this both we multiply by the conjugate of the denominator. Then this is 10 times 3 minus I divided by 3 plus I times 3 minus I. Here 13z, this conjugate is 2 plus 3 I know. Multiply both denominator and numerator by conjugate of the denominator 2 plus 3i. Okay. Now, people simplify this. Here, a plus b into a minus b. A squared minus b squared coming, no? 3 squared minus I squared. Here, a minus b into a plus b. A squared minus 3i squared, like this. Here, people, I squared is minus 1. That and this plus. Then 3 squared plus 1 means 9 plus 1, 10. Right? I squared is minus 1. Then this plus 3 squared is 9. 9 plus 4 is 13. This and this you can cancel down. This and this you can cancel down. U equals 3 minus I plus Z times 2 plus 3i. Right now, people. That answer we got. Okay, people, now second one given like this. Up to here, I think you can understand the simplification now. People, this lesson is very easy if you remember all the theories. Now you can see the theories we learned in the lesson at the beginning. We use again and again in different ways. That's what here you have to manage. So other than that, of course, nothing. The lesson is easy. Therefore, you have to do lots of questions in order to remember and keep permanently in your memory the theories. Right, people, even though the theory is available permanently in your memory, it is not useful. you should use them very often until you very much familiar with the lesson. Then only people that stored the memory, you can meaningful way use. You know all the theories you have in your memory, you can remember, but you know the way you use them, people. Understand? If you don't know how to use them, people, even though you have a good memory, that is useless. So that is why we must do more sums. Okay, so therefore at least the same sums do, people. Then only the present memory you use, and then only you can very easily manage the theories to get the answers. Okay, that experience is very important. But most of our students, they think that just covering the theories, that's enough to do any question in the lesson. No, people, not anyway true that statement. Covering the theories means, people, you just know this kind of thing available, this kind of lesson available. But though you know just the theories, people, don't think that you can work out questions. Okay. But these all are theories, people. Now this one you can very easily prove. But so this proof we are going to use in another location in the question to get the answer. So that practice, if you don't have, you can't work out the question. Right. Now we'll come to the next part. We are given, people, like this. The complex number u is such that u minus 3 plus I modulus is 13. Right. We'll come to that now. Now u is such that, given this way, people, u minus 3 plus I modulus is 13. U complex number is satisfying this condition, such that this way. Right. Show that mod z equals root 13. Now, people, by this result, using u equals 3 minus I plus z times 2 plus 3i. Right. Bring this to this side. U minus 3 plus I is equal to this. Right. Then we need to find the modulus. We are given the modulus of this, no? This complex number only here we have. Then I can put, right, people? I can find the modulus of this. This is a complex number, no? U is a complex number. Subtracting 3 from that, the result u minus 3 is a complex number. Adding I to that complex number, I is a complex number. U minus 3 is a complex number. Sum of two complex numbers is another complex number. So therefore, left hand side we have a complex number. Then its modulus mean, people, since it is equal right hand side, modulus of the right hand side. Okay. Then here this is a complex number, this is a complex number. Then product of two complex numbers we have. People, you can remember when we have product of two complex numbers as z1, z2, its modulus, people, we proved is equal to z1 modulus into z2 modulus like this. So then I can write this one as mod z and mod of this. Okay. People, modulus of this complex number 2 plus 3i. How to write the modulus of a complex number? 2 plus 3i is a complex number. Its modulus means real part squared plus imaginary part squared root. No? Right. So then I can write mod z times this is root 13. And in the left hand side, u minus 3 plus I modulus given as 13. Therefore, this is 13. This is 13. Cancellation of this and this gives rise, people, root 13. Therefore, this implies us mod z is equal to root 13. Mod Z is equal to root 13. That we got. Right now, people. Right. Show also that another two parts given, A and B. Show also that mod Z equals 13 we proved. Show also that if real part of U equals 3, then Z is this. Right. People, now try that question, that part. Try that part. Right. Now we proved that U equals 3 minus I plus Z 2 plus 3I. Right. Now people, suppose we have this way. Two complex numbers, Z1 is suppose 3 plus 2I, Z2 4 plus 6I. Now suppose we add Z1 and Z2, then what do you get? 3 plus 2I plus 4 plus 6I. This way, no? Then I can write this 3 and 4 real parts together, I times 2 and 6 the imaginary part together, the Z1 plus Z2. Then of this Z1 plus Z2 complex number, if I find the real part, it is nothing but this, no? 3 plus 4. What is this 3? That is this 3, no? It is nothing but real part of Z1. And this 4. 4 is nothing but this 4, real part of Z2. Then here we have real Z1 plus Z2 is this. Okay. Understand it? Right? Therefore, I can write here, U is a complex number. It is sum of two complex numbers. This is one complex number and this is another complex number. Because this is a complex number, Z is a complex number. Their product is another complex number. That is how we argue. We have proved them at the beginning. Then if I need to write the real part of U, then that should be equal to, since U is the sum of this and this, real part of this complex number, right? It is 3, very obvious, no? Real part is 3, no? Plus real part of this whole complex number, real part of this 2 times Z plus 3I. This is. But people, given that real part of U as 3, this is given to be 3. Then I can put that 3 here. Just see, this and this you can cancel down. This gives us, people, real part of this complex number. This is a complex number. This is a complex number. Z 2 plus 3I is a complex number. Their product is another complex number. This is 0. Then this is a complex number, right? Of this complex number, real part is 0. People, we proved in the theory case, if the real part of a complex number is a 0, if real is 0, can remember we proved Zn minus Z bar become equal. Understand? We proved that. So therefore, this is the complex number. Its real part is 0. Therefore, this relation I can write. What is the relation? This complex number, therefore, z times 2 plus 3i complex number is equal to minus the conjugate of the same thing. Conjugate this way. Okay. Then you can see here, right? Then you can see here, I can take the conjugate of this z and this both, because here this is a complex number, this is a complex number, their product there we have. Therefore, minus, this is z bar. The conjugate of this going to be what, people? 2 minus 3i, no? 2 minus 3i. And here we have z times 2 plus 3i. Right, now I need to find this z. Then what I do is this, people, I multiply both sides by z complex number. Then here we get z, then this multiply z become z squared 2 plus 3i. Z bar 2 minus 3i. Right. People, z bar mean what? Mod z squared. Mod z, people, we proved root 13, no? Then mod z squared is 13. Right. Now, when you simplify this way, you can take this answer. Right. So then I can write z squared times 2 plus 3i equals minus z bar means mod z squared 2 minus 3i. Mod z squared mean, people, 13 2 minus 3i, and this z square subjective bring this to denominator like this. Right. Now what we do is, people, we multiply this numerator and denominator by the conjugate of the denominator and keep simplifying, take the root, then we get 4z 2 answers, these 2 answers, right? Minus 13 2 plus 3i 2 minus 3i. This way we get. Then I can write here z squared equals minus 13. This is 2 minus 3i perfect squared divided by, this is like a plus b into a minus b, no? That is a minus b perfect squared. Therefore, 2 squared minus 3i perfect squared means there we get 13. Correct, no? A squared minus b squared. These 2 you can cancel down. People, now z square, this minus sign I can write as I squared 2 minus 3i perfect squared. Now this square and this square you can write within one square like this. Okay. Then we'll multiply this by this I inside this bracket. It's now 2i, I and I squared minus 1. With this minus 3, we get plus 3. Perfect squared. It is z squared here. Now, people, you can take the positive square root, right? Sorry, not positive square root. On the right hand side square root, you have to put plus or minus. Plus or minus. This implies z equals plus or minus 3 plus 2y. That's how we take that answer. People, we can have another method. That method also you can use. What is that, people? We take z dash x plus iy. Then multiply these two. Then we equate real part to 0. Thereby taking two equations, finding x and y, you can take the same answer, but that method, I think, a little bit longer than this. Okay, second part. Immediate part of u is -1. Then we have to prove this. Immediate part of u is -1. Right, I will count that. U is this. Immediate part of u is people -1. Right. So then u contains as sum of two complex numbers. Then of that sum, immediate part mean people what? Sum of the immediate parts of the complex numbers. So therefore, this is given. This is given. But immediate part of u is people. Here immediate part is u of this complex number is -1, and immediate part of this. Immediate part of this complex number. So times 2 plus 3i. Right, people? By using this, I wrote this result. U is this, no? Sum of these two, no? Then immediate part of u means immediate part of this plus immediate part of this. So immediate part of u is -1. Then here -1, -1. Im is said 2 plus 3i. This two you can cancel down. This implies what, people? Immediate part of z times 2 plus 3i. Right, today we proved, people, but in the same part we proved, if immediate part of a complex number is 0, z equals z bar. This we proved. Therefore, this is the complex number. Its immediate part is 0. Then this complex number is equal to its conjugate. Now this implies z times 2 plus 3i is equal to its conjugate. Z 2 plus 3i is it. Okay, so then I can write z times 2 plus 3i. This is z bar. This is 2 minus 3i. Then multiply this by people z. Then we get z squared 2 plus 3i. Z bar 2 minus 3i. But z bar means, people, mod z squared. It is mod z squared. Mod z squared. Mod z squared is, people, 13. 2 minus 3. I bring this to the denominator this way. 2 plus 3i. Here this is z squared. Now 13. We multiply this by the conjugate of the denominator. It is 2 minus 3i. This way. Then here we can write a plus b into a minus b means a squared minus b squared. That means 2 squared minus 3i squared. 13 coming. This is 13. This and this you can cancel down. Z squared is equal to here 2 plus 3i perfect squared. Therefore, z equals plus or minus 2 plus 3i. This is how we take that. See there, the way we use the proved result at the very beginning of the question. So therefore, people, most of the time, when we are given a question like this at the examination, if there are some results at the beginning to prove, most of the time, people, that proof are very important to take the answers of the latter part of the question. So therefore, you have to always try to link that proved theories at the beginning of the question to take the final answers. There can be some alternative methods, right? Here also, this method, even though I use like these people, actually there is another way. That way, the simplification is a bit longer than this. Okay. So then, anyhow, people, now after proving something and given a question and hence show a particular answers, means definitely there you have to use their theories, no? So that is the important thing. If you do the question in another way without using their theories while you are given the hints, then you won't get marks. That occasion, you have to very carefully think how to match the given proved theories to get the answer finally. Okay. Right. So therefore, this question is I did like that because to use the proved part at the beginning. Yeah. People, now we'll come to the next one, number 21, as the next question in the tute. Take number 21 as the next question. Number 21. Read number 21, people. Number 21. Right. A complex number is given by cos theta plus I sin theta. Then you know, people, its modulus, you know, it's 1. Why, people? All right. Usually modulus we define to be this, we know, if we consider the polar form of the complex number before the bracket, having cos theta plus I sin theta form before the bracket, what do you have here? It is the modulus of z. Like that, here we have 1, that place. Therefore, mod z is 1. And the other one is z bar is equal to cos theta minus I sin theta. Right? Then we have to prove 1 upon z is equal to z bar. Yeah. 1 upon z means really this. 1 upon z means cos theta plus I sin theta. Then I can multiply, people, the right hand side, both numerator and denominator, by the conjugate of the denominator. Conjugate of the denominator going to be cos theta minus I sin theta, no? Right? Then here, cos theta minus sin theta. Then this is a plus b into a minus b. Then I can write right. It is a squared minus b squared. It is now cos squared theta minus I squared sin squared theta. I squared is, this is minus 1, that minus and this minus make plus. When we get cos squared theta plus sin squared theta, it is 1, no? This is really 1. Then we get 1 upon z like this. Cos theta minus I sin theta. Cos theta minus I sin theta, it is nothing but z bar. Right? So therefore, 1 over z is equal to z bar. This gives us z bar is equal to 1 upon z. Right? So people, you might ask this way too. What if we straight away do this way? Z bar equals 1. It is mod z squared using this result. But mod z is 1. Therefore, 1 squared z bar equals 1. Then z bar equals 1 upon z. If we prove like this, you can use that, use that people, but you have to prove this. This way we can use, but you have to prove this. This proof is including everything. So therefore, when you straight away use this one, in that case, without proving this z bar equals mod z squared, that can be a reason to lose 5 marks. Okay, or 10 marks. That is another way of proving. Therefore, we have to remember to prove this. Right? That part is okay. Right. Prove that cos theta is this. Right. Now, people, you know, z is cos theta plus I sin theta. Z bar, it is equal to cos theta minus I sin theta. And just now we proved z bar is equal to 1 upon z. That we proved. Now, if I add this z and z bar, people, z plus z bar, when you add, what you get is this I sin theta and this minus I sin theta will cancel off. This is 2 cos theta. That gives us cos theta. This 2 comes here, half z plus z bar. But people, z bar, we proved here itself, z bar is 1 upon z. Z bar is 1 upon z, right? Cos theta is half. Z bar mean people 1 upon z. That answer is okay. Right now. And secondly, we'll take z minus z bar. Z minus z bar. Is this and this we can cancel down. 2I sin theta. In subject sin theta. 1 upon 2I. Z minus z bar. Z bar is 1 over z. That answer we got. Okay. Okay, people, now we are given 3 complex numbers, uv and w like this. uv and w like this. Right, now just try the rest part. Right, people, we'll see how to take this. You are given the 3 complex numbers u. U mod z squared divided by z squared plus 1, right? V. mod z squared plus 1 divided by z squared plus 1. And next one, w. Z squared plus 1 divided by z squared minus 1. Z squared plus 1. This way you are given. Given that z not equal to plus or minus I. Right. Now, ask him what? Prove that u equals this answer, v equals this answer, w equals this answer. Right. Okay, now here, the easiest way of getting this answer, people, u mod z squared, that we write as z bar divided by z squared plus 1. Right now, mod z squared is equal to z bar. Now, I can divide both this numerator and denominator by z. Z bar divided by z plus 1 upon z. Dividing numerator, denominator by z. People, z plus 1 upon z, we proved an answer for this. Z plus 1 upon z. 2 cos theta, no? We put 2 results like this, no? Cos theta. Cos theta, it's half z plus 1 upon z. Sin theta, 1 upon 2i, z minus 1 upon z like this. Then z plus 1 upon z, 2 cos theta here. Z bar, cos theta minus I sin theta, no? Z plus 1 upon z is 2 cos theta. Then we can take this 2 before. It's half cos theta 1 minus I sin theta by cos theta tan theta. This way we get that. Right. V, the next one. V is this mod z squared plus 1 divided by z squared plus 1. This mod z squared, people, we can write as z bar. We proved it, no? In the same question we proved. How? That z bar equals 1 upon z. Once you use the cross multiplication, we proved this, no? Z bar equals 1 upon z. This way, when you multiply, z bar equals 1. This 1 is nothing but, people, of the given complex number modulus, no? So therefore, in that proof includes, right? Okay. Now, plus 1 divided by z squared plus 1. Then again, I divide the numerator and denominator by z, right? Then we get v equals z bar plus 1 upon z divided by here z plus 1 upon z. Then we know here, we proved this 1 upon z. This 1 upon z, people, we have proved this equal to z bar. Then this is z bar. And this also is z bar. So this is z bar. Z bar plus z bar is 2z bar. Z plus 1 upon z is 2 cos theta. This two you can cancel down. then we get V cos theta minus I sin theta is the Z bar divided by cos theta. Then we get V as cos theta by cos theta is 1, sin theta by cos theta is tan theta, 1 minus tan theta. V equals 1 minus I tan theta. Third one, W, z squared minus 1 divided by z squared plus 1. Divide here also the both numerator and denominator by z. Dividing both the numerator and denominator by z. This is what we get. Z minus 1 upon z is 2y sin theta. Which is 2 cos theta. In this way we get W equals I tan theta. W equals I tan theta. Okay, now some questions asking, hence show that U plus W equals half 2 minus V. U plus W, right? Become that now. U plus W. U is this, no? Half 1 minus I tan theta. Plus W. I tan theta. Then once you simplify this, we get half, right here, divided by 2 multiplied by 2, 1 plus I tan theta is the U plus W. Right. Now let us see what is this. Next one, half 2 minus V. Half 2 minus V. V. I 1 minus I tan theta. Here. Simplify this. 2 minus 1 is 1, minus minus plus. Right? We get like this. You can see here half 1 plus I tan theta, half 1 plus I tan theta. The right hand side is equal. So therefore the left hand side must be equal. This implies us U plus W is equal to half 2 minus V. That answer coming. Okay, now people next. Next part. Right, there you are given U equals half. Part 1. U equals half. But what is u? U is, we proved this u to be half 1 plus I tan theta equals half. This and this you can cancel down. You get 1 here. 1 minus I tan theta is people. It's 1. Then you can very clearly see this 1 and this you can cancel down. This implies tan theta is 0. Then theta can have two answers, theta 0, theta pi people. Because we are given this theta is in the region, this no. In the question we are given this theta, this than or equal to pi, greater than minus pi, this region. Okay. Okay. Then asking this is it no? Then Z was what people? Cos theta plus I sin theta, no? This theta only here we have. Theta has two answers. Theta 0 gives us Z cos 0 is 1. Sin 0 people 0. Then Z is 1. Theta is pi. That gives us cos pi minus 1. Sin pi 0. So the two complex numbers for Z are those. Second one. Show that the complex number Z which satisfy the equation imaginary of V is minus 1. Imaginary part of V. Imaginary part of V is minus 1. But what is people V? V, complex number V, we found to be this way, no? Minus 1 minus I tan theta. Then imaginary part going to be minus tan theta, no? Here, minus tan theta. Minus 1. Then tan theta people? 1. What are the two answers for theta according to the region that theta given? Theta has two answers, people. One is pi by 4. The other one is the region of theta is what? This end it can come to what? Plus pi. This end it can come to minus pi. In tan theta 1. People, tan theta 1 means tan theta positive, no? This can happen in the first quadrant and third quadrant. Since according to this region of theta given us, theta can go in the positive sense up to plus pi. In the negative sense, it can go to this way up to minus pi. Then in this indicated regions of theta, tan theta positive occurs in the first quadrant and third quadrant. Then there should be two angles. One is theta pi by 4, first quadrant angle. Other one is people, this third quadrant, pi plus pi by 4. Tan 180 plus 45 is what, people? Tan 45 plus 1 coming. Tan 180 plus 45 is tan 45 plus 1 coming. But that way you can't take, because the maximum angle in the positive sense we can move is what, pi. That location is this, having this is pi by 4. Then anti-clockwise sense you can't come up to this position. Why? Then this theta range plus pi, it is exceeded. Then we have to go that from clockwise sense. What is that? When I come up to this minus pi, before minus pi, an angle pi by 4, we have to stop. Right? Then what is the angle? Theta minus pi when we come to this position. But we have to stop. What, people? pi by 4 before. That means plus pi by 4. Okay. Correct, no? They are the two angles for theta it can take. Right. Then this is really nothing but minus 3 pi by 4. Right. Minus 3 pi by 4. Right. Yeah. Then you can write the two corresponding complex numbers for Z. Two corresponding complex numbers for Z. When you simplify these two, we get minus 3 pi by 4. Then what are the Z values? Theta equals pi by 4 gives us. What is Z? Cos theta plus I sin theta, no? At the very beginning of the question we had been given, no? Right. Cos pi by 4 plus I sin pi by 4. Then 1 plus I 1 over root 2. Right. Next one. Cos this angle minus 3 pi by 4. I sin minus 3 pi by 4. People here, cos minus theta is cos theta, no? Then we can write this as cos 3 pi by 4. Sin minus theta minus sin theta minus I sin 3 pi by 4. Is it? Cos 3 pi by 4 means what, people? Cos 135. Second quadrant minus 1 over root 2. Minus I sin 135. 1 over root 2. Z is minus 1 over root 2, 1 plus I. Then here, two answers. We have one is with plus sign, other one is with minus sign. That's how we take the two answers. Right. Show that the complex numbers Z which satisfy the equation W equals I over root 3. 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 Right. Our W complex number we found I tan theta, no, people? W is I tan theta, no? This is I tan theta, no? I over root 3. This and this you can cancel down. Tan theta is 1 over root 3. Tan theta is 1 over root 3. Okay. Then you can write for tan theta 1 over root 3, people. Theta pi by 6 as before. And the other one is minus pi plus pi by 6. Right? This one is nothing but minus 5 pi by 6. Okay. Then you said we can write cos pi by 6 plus I sin pi by 6. Cos pi by 6, you know, root 3 by 2. I sin pi by 6 is half. This way we get something. Next one, minus pi by 5 pi by 6. So it cos minus 5 pi by 6 plus I sin minus 5 pi by 6. Cos minus theta is equal to cos theta. Sine minus theta minus sine theta. People, 5 pi by 6 is 150, no? 5 by 6 into 5, no? 150. Cos 150 is, people, minus cos 30, no? Cos 150. 150 angle we can write as 180 minus 30, no? Cos 180 minus 30 is minus cos 30. Minus cos 30. Cos 30 is root 3 by 2. Here, I sine 5 pi by 6. Sine 150. Half. Then we get Z equals minus half root 3 plus I. The other angle, yeah, we found here. Then these are the two answers, right? Okay, people, then try all the questions. Another one thing, on the two theories we have to discuss. Those theories I am going to discuss this coming Friday class, right? Then I'll put the recording in that class also. Okay, now do all the sums in the tutorial, right? Yeah, any question here today?